Hello and welcome to the Cahokia Archaeological Society. Before we start our presentation tonight, we are going to announce the two winners of our 2025 CAS Scholarship and Grant Opportunity Awards. So we're going to take a minute to do that. The awards support emerging scholars whose work contributes to meaningfully to the field of archaeology in the greater Cahokia region and beyond. So the first recipient we have is with us tonight. Her name is Christina Young-Peter. You want to come up? And grab your letter real quick. Okay, so Christina is a doctoral candidate with Washington University in St. Louis, and she's advised by Dr. Natalie Miller. Christina's dissertation focuses on lost crops agriculture in Cahokia, or at Cahokia, offering new insights into agricultural strategies of its ancient inhabitants and establishing innovative archaeological methodologies. With the support from CAS, Christina will attend the 11th International Symposium on Biomolecular Archaeology in Turin, Italy this August. Her participation will elevate international awareness of Cahokian-related research, expand her professional network, and further her dissertation work. Christina has practiced archaeology in the Midwest for 5 years. She has earned a BA in anthropology and archaeology from the University of Cincinnati in 2020. And since moving to St. Louis in 2022, she has worked as an archaeology technician for the Illinois State Archaeological Survey, contributing to the Phase 3 excavation of Stempler, a Sterling Mound Moorhead phase site in the American Bottoms. So congratulations. Thank you. Thank you. Congratulations. Our second recipient is not here tonight. She lives in Philadelphia, or in Pennsylvania, and it's Autumn Milby, a doctoral candidate at the University of Pennsylvania, advised by Dr. Megan Castlebaum. Autumn's research centers on the Hawkins Hollow site in Valmeyer, Illinois, exploring the lived experiences of rural Native American communities during periods of social change. While conducting fieldwork at Hawkins Hollow, Autumn and her team stayed at Camp Vandevanner, a Scouting America group, a camp located between Waterloo and Valmeyer, and there she collaborated with camp rangers to develop an archaeological merit badge program, sparking a deep interest in public outreach. With CAS support, Autumn is formalizing a comprehensive archaeology merit badge day programming package for use by avocational societies and social science educators. This initiative builds on 2 successful prior events organized by the Southern American Bottom Archaeological Project at Camp Vandevanner. The final project will include a digital booklet and published guide detailing logistics and programming to meet nearly all requirements for earning the Scouting America Archaeology Badge. Autumn will present the preliminary programming and workshop stations at the Conference on Public Archaeology in Washington, D.C. on August 10th. The finalized package will debut during the inaugural Archaeology Merit Badge Day on September 6, 2025, hosted by CAS, Camp Vandevanner, and ISAS. Feedback from this event will inform final revisions, with additional review provided by tribal consultants from the Quapaw Nation's THPO and 2 Scouting American regional councils. Autumn's goal is to foster meaningful relationships between archaeological societies and scouting organizations, strengthening community engagement and cultural heritage stewardship through the greater Cahokia region. So congratulations to our first scholarship recipient. Thank
you. Okay, just a few announcements for upcoming activities that we're associated with here at the Cahokia Archaeological Society. On this coming Saturday, the 26th, we'll be working with the Illinois State Archaeological Survey, doing some artifact washing for the folks there. If you haven't signed up already, please, if you're interested, you can go to our website and find information about how to sign up for that. We're also looking for volunteers to help out at the Illinois State Fair, August 8th through 18th. Help man a booth for our parent organization, the Illinois Association for Advancement of Archaeology. On August 16th, we're doing our first artifact ID roadshow at the Monroe County Historical Society Museum in Waterloo, starting at 1:30, and you can sign up via email, excuse me. And then I have our regular meeting on August 21st, and Sarah Bears, who's with the Illinois State Archaeological Survey, will be doing a presentation on some of her research associated with this area. And then on September 6th, we're working with the ISAS folks again, with the folks on the Boy Scout Merit Badge at Camp Vandavander in Waterloo. So we've got a lot of things going on, and we encourage people to help and participate in any of these activities. So tonight, our presentation is by Simon Sherman III, doing his postdoctoral research at Washington University. And he'll be doing a program tonight on some of his work and analysis he's been doing with Poverty Point and the various types of cherts, or flint, for some of you who prefer that term. And so I'll turn it over to him at this point. Simon, you're on.
All right. Well, hey, everybody. Thank you so much for having me here today. Thank you so much to the Cahokia Archaeological Society. And thank you, Bill, for the invite. Today I'll be sharing some of the work I did for my dissertation about 2 years ago, and the work that's constantly ongoing, which focused on the non-destructive analysis of cherts and other materials used to make stone tools. So you think of bifaces, projectile points, PPKs. But in this case, we're not focusing on arrowheads, which are more characteristic of later periods. We're mainly focused on atlatl darts or spears or projectile points. And so basically, I'll walk you through how I used reflectance spectroscopy to analyze these tools, and I'll present some preliminary results from a broader sourcing study, which focused on stone tool materials from the Ozarks within Missouri and Arkansas. And then finally, I'll use those Ozark resources to highlight some new findings at the Poverty Point World Heritage Site in northeastern Louisiana, where I'll apply this sourcing approach to better understand how raw material use and regional interactions are happening within both the lower Mississippi Valley and the central Mississippi Valley. However, before I dive in, I just want to quickly define a few key terms. The first would be sourcing. So trying to figure out where that material was used to make the artifact and where it originally came from on the landscape, whether that be some type of differentiation within the visual or the chemical, elemental, or reflective properties of that material. And then the next term would be provenance, not to be confused with provenience, which is more context-based or about a find point, but rather the geological source of that material and the history of that material that makes it it. And then finally, the third term would be the archaeological sciences, or archaeometry, which is just a range of different scientific or more analytical, less inner observer error approaches to try to answer those various archaeological questions. However, it worked good. Before picking apart different rock types, it's important to step back and think about the bigger picture. What kind of questions are we trying to ask? First, you got to consider the scale and the direction of any kind of sourcing study really depends on how we frame human behavior. So in this case, we're thinking about how past peoples, especially pre-contact groups living in North America, use those chipstone tool resources. And these are mainly made of chert, but they're not exclusively, subject to chert or flint. There's also quartz sandstone. There's igneous material like rhyolites and silixites, which have a various geological range and also chemical signatures. So rather than just identifying rocks themselves, this research is ultimately about how understanding people were selecting and using and moving these resources across the landscape, and in some cases is over great distances. So let's talk briefly about some of the main methods used within sourcing studies. The first would be visual, macroscopic, or lens-based analysis, which is just relying on things like the color, the luster, the translucency, and in some instances texture to distinguish different materials. This is one of the earliest approaches, not only because it's super easy, but there's also, it's cost effective and it's very simplistic. And some people are extremely good at it. Some people, like Phil Carr in Alabama, typically you'll go out to archaeological sites and you'll, over the course of your career, collect from a bunch of different pre-contact quarries or outcrops or road cuts, and then, carry that in your van or your vehicle or your car and take it to an archaeological site and then look at the projectile point or chip, debitage, and then look at the rock and say, oh, I think it's this. And some people are fantastic at it. However, it's more of a complementary aspect to sourcing rather than more analytical ones. And then the next would be petrographic analysis, which actually you're creating thin sections, so you're cutting into the rock or the stone, and you're trying to examine through the microscopic lens what inclusions or different textures, what types of minerals are within that microscopic level. And then finally, there's the geochemical, which has gained a lot of traction in recent years. So you're mainly focused on the elemental composition or the isotopic geochemistry of that material, and it can take you even to that particular quarry site, that deposit, which can tell you a lot more about the greater formation within that deposit. And increasingly, researchers are finding the most effective way to do this is either use all of them or a combination of some. So there's this approach called the multi-layer analysis. So you'll look at the material, you'll cut it open and make a thin section out of it, and then you'll zap it or break it up into a powder and actually look at the elemental chemistry of that material. And so we can get more nuanced interpretations of past human behavior doing this. And so this is called a multi-layered or hybrid approach. So when we do raw material studies like this, there are a few research aspects we have to consider. First, again, that I'm going to keep harping on is what is the research question? What aspect of human behavior are we trying to really understand? And again, this really does help set the scale and how many samples we're going to need and how broad and focused that study is going to be. So if I want to go to Burlington, how many deposits within that formation is going to be representative of that greater formation, or within more detailed intra-formational analysis, where are people going to get certain materials at a greater scale? And so a major driver for this scale is the geologic and geographic distribution of those different raw materials, being quartz, sandstones, and cherts. Are they widespread? Are they localized? Are people creating expedient versus curated tools out of them? What influences both our sampling strategy and our expectations about the sourcing accuracy are these questions. And so finally, one of the most important things is the variation, and this is the most important aspect of analytical chert sourcing. Ideally, is there enough variation between different formations or sources, but not too much variation within that single source, so we don't, it doesn't create a kerfuffle. How can we tell them apart? Is there variation enough to pick out different geologic deposits? And to get at that, we use different statistical tools to measure this variability. And that variability often lies on how that material was formed. And this is based on the paleodepositional environment or specific microenvironments of where that material eventually landed within the silt or the clays and that landscape that can tell us a greater story about it. This concerns again with how that material formed. So the more we have an understanding of the geology, the paleodepositional environment, the microenvironments, all of these things behind these materials, we can more confidently build a sourcing framework or representative comparative database that reflect both natural and cultural anthropogenic processes. So I'm sure many of you here are familiar with Burlington limestone, Burlington-Keokuk, Burlington Chert, which is one of the most widely used materials in this region. But however, for those of you who aren't familiar with this material, Burlington occurs through central and southwestern Missouri. And the geologic formation extends itself into parts of Oklahoma and Arkansas. And it's highly variable, both in its quality as well as its appearance. But for some reason, I think it's because it's such a big overarching geological formation within the center and southwestern part of the state, that it's a preferred material to create bifaces throughout time. And in fact, Ozark materials are being tentatively identified at places like the Carson site in the Mississippi Delta or North Mississippi, the Yazoo Basin, which is a Mississippian period mound center, so somewhere between 950 to 1550 AD, with ties to Cahokia, and it's even further back in time, at least visually, Burlington is, at the Poverty Point World Heritage Site in northeastern Louisiana. So much of what we know about this material and these types of materials in the Ozarks has to do with the work that Jack Ray did in, from the late mid-80s all the way to, his seminal work in 2007. However, despite these types of efforts, we still face challenges, particularly around the complex geology of the Ozarks as a physiographic province. And it's also important to note that there's several different types of geological processes and age within the Ozarks. So you have sedimentary materials, which could be somewhere from 330 million years old at the Mississippian epoch age, all the way to igneous material like rhyolite and silicite in the central or southeastern portion of the state within the San Francisco Mountains that are like 1.3 to 1.5 billion years old. So you have a lot of variation in age and different processes. So one of the big questions remains, can we consistently and clearly separate out these different materials in both time and space? And that's a big part of what this research is trying to address. Hey, awesome. So what can characterizing Ozark materials really tell us more than just rock types? It reveals how people moved, how people traded, how sociality was organized, how the complex structure of the site was, how people were intermarrying or what have you, and it's all about interaction. So it can link artifacts to specific quarries, and that therefore certain behaviors, and in some cases, rocks can be a proxy for people. So we can track how materials are shared or controlled through time, and again, it's not just Burlington Chert, it's where, when, and why that source was used in the past. However, getting at that level of resolution takes a lot of analytical precision, and since Chert can vary a lot, in a lot of cases it's 97 to 99% silica dioxide, so just a single compound or mineral, and even within that same formation, so all of that paleodepositional environment is our key to try to differentiate those types of materials. And the goal of those methods is to let us distinguish not just between formations, but within them, down to the individual deposit, and then where that depositional environment matters, like pressure, heat, chemistry, and leaving unique signatures of the stone. And I hate to use this term, but it kind of serves like a diagnostic fingerprint to trace that material's origin back onto the landscape. Okay. So the main technique I use in this is non-destructive reflectance spectroscopy. The two instruments that we use are the VNIR and the FTIR. The VNIR stands for Visible Near-Infrared Reflectance Spectroscopy, which measures to the beginning of the visible to a portion of the near-infrared spectrum, and then the FTIR instrument picks up where that other one left off that measures from that portion of the near-infrared all the way to a portion of the middle infrared spectrum. So very complex instruments, but what's really cool about these is that they're non-destructive, so there's lots of ethical considerations, especially with culturally invaluable artifacts. And I don't want to sell other techniques short. There's also X-ray fluorescence, or PXRF, which tells the elemental geochemistry. However, there's certain nuances to that instrumentation, which are less robust than this one. And I can go into that later or through correspondence if you would like. But so again, it's non-destructive. It's very similar to PXRF, but a big problem is that a lot of these techniques are destructive. And again, with NAGPRA and other ethical considerations, we have to think about that. And again, it's not geochemical. It's not a specific element. So you're not looking at copper or gold or strontium or zirconium and all that kind of stuff. Rather, we're looking at how those stone molecules are arranged. and each deposit will reflect light, and that light will be reflected differently based on things like the clay and the quartz and the various iron contents within that material. And by analyzing how this light is absorbed, we will get unique, non-destructive fingerprint of that material. And it's likely, and it's particularly important in archaeology, where sourcing has traditionally been done visually, especially in the southeast United States, where whole careers have been made just looking at the rock. So we can move forward with this. And this approach, while not perfect, offers a way to reduce inter-observer error and minimize damage to the artifacts that I've already beat on, and then boost our confidence in identifying those different raw material sources. So in early January 2025, I met with my colleague Ryan Parrish in Springfield, Missouri, at the Missouri State Center for Archaeological Research, or the CAR, with the help of Jack Ray, to conduct a large-scale non-destructive analysis of about 650 individual samples, encompassing 10 different material types and 7 different formations within the Ozarks. And we analyzed different cherts, different quartz sandstones that are often conflated and called quartzite when they're actually sedimentary rather than metamorphic. And the goal was ultimately to test whether reflectance spectroscopy could differentiate these different deposits or these different formations or these different colored formations from each other, not only based on the reflectance data, but also, if they're of different age and different processes, you would think, okay, they'll show up differently. And so this forms the foundation of our comparative database that we can then use to analyze different archaeological artifacts moving forward. So I've run a few statistical tests of those materials from the Ozarks. And now we can kind of answer the first question: can we separate igneous material that's 1.3 billion years old from sedimentary material that's somewhere around 330 million years old? And the answer is yes, we absolutely can. On the far right, far left, I'm sorry. I can never tell my distance. But right here, these are both igneous resources. So those are from the San Francois. Those are 1.3 to 1.5 billion years old. And then we have this cluster here, this kerfuffle. This is all a bunch of quartz sandstone and chert materials from the Ozarks. So you would think, oh, the method doesn't work. However, there is a really high quality material called Reed Springs chert that's widely used from the Paleo-Indian all the way to, I think, Woodland Mississippian period. I could be wrong. I'm still reading the literature, so please forgive me. But it's right on this tertiary area. So, okay, these quartz sandstones and these cherts from the Ozarks are overlapping over here. But for some reason, this Reed Spring chert sample is kind of out on its own in no man's land. So that's a good sign. And then another would be this Pitkin material collected from Newton and Searcy counties, Arkansas. And it is actually younger in age than Burlington limestone, but they're both from the Mississippian epoch. So again, 330 million years old. And it speaks to non-destructive reflectance spectroscopy because of the paleodepositional environment. For example, Pitkin has a high amount of organic content, and it's also visually discernible. But the really cool thing about Pitkin is that it contains a lot of petroleum. So when you crack open Pitkin and you smell it, you can smell oil. So it seems that non-destructive reflectance spectroscopy is working here, at least differentiating igneous and sedimentary resources. Again, these are small samples though, and we have to keep collecting to create a representative sample for this database. So when I say small samples, I mean somewhere between 15 to 45 different artifacts. So again, the age-old, we need more data. Please give me money, more funding. But this is promising. And it shows that more samples and more complementary techniques are needed, but we can confidently source artifacts. And now we can try to answer the second question, okay, can I pick out an individual formation and can I differentiate or discern or pick apart different quarries within that formation? If not, well, okay, maybe I can just say, oh, it's this formation versus this formation. But if we can go down to the quarry level, we can start talking about quarry cluster approaches, least cost pathways, movement, ravine versus terrestrial, highways to get back into a different thing. So what I did was focus on Burlington, and that's because we had so many different deposits, well, not so many, but we had 5 different deposits of that Burlington. And what you can see is 2 out of the 5 Burlington pre-contact quarries separate out. So that's good, about 40% hit rate. Not great, but good. And then we have these 3 varieties here that all have overlap. So perhaps if we have bigger samples due to a small sample size, we can, clearly those little ovals or circles, will separate out. And that way we can say, okay. And then what we'll do eventually with the artifacts is that we'll rerun a model and, zap a projectile point or something to say a spear arrowhead from Cahokia, and then we'll run the model again and we'll see where that black dot, that black triangle, that black plus, that black circle, whatever, falls within one of these or outside. If it falls within one of these, we can say, okay, I'm pretty sure it came from the High Ridge Variety Quarry, or I think it came from the Crescent Quarry right here, or I think it came from the Hominy Creek Quarry. And then we can really start putting the feet on the artifact and think about other types of social pressures on material resources. So now that we've shown that we can distinguish between different formations, but also at the deposit level within that same formation, we can start applying this Ozark material to a more comprehensive data set. And by combining it with more geologic reference samples, we can now investigate the origin of unknown tool types. So like the previous example I used with Cahokia, well, my case in point is the Poverty Point World Heritage Site in northeastern Louisiana. One of the big things to consider is that there's a lot of trade occurring throughout the Southeast, the Mid-South, and Midwest, and this kind of helps us ask bigger questions about mobility, exchange, trans-egalitarianism, inequality, all that kind of stuff. And one great example is that exotic materials can reveal whether there was open or restricted access to different sources. This is a really popular thing during the Mississippian period for Burlington sources, but now we can try to answer those kind of questions at even older site. So take the Poverty Point again. Take that for an example. There's a wide-ranging trade network that's occurring from 4,000 to 2,000 years ago. However, the Poverty Point site, the apex is somewhere about 3,300 years ago to 2,980 years ago. And there's 6 big mounds, one from a later culture. There's the biggest of the oldest mounds in North America, behind Emerald Mound in Mississippi and Cahokia here in Illinois. But there's also 6 semi-elliptical earthen ridges that were constructed similar to the mounds, and a lot of people would postulate that it kind of resembles Burning Man. To each his own, do your thing. However, what's clear is that people and materials are coming from far away, and considering the Poverty Point site is the nearest snappable stone source within the Poverty Point sphere is about 30 kilometers to the southwest, and it's of very poor quality and low package size. It's not unreasonable to think that they're getting their materials from elsewhere. Oops. What are you doing? Old school. Awesome. So as I mentioned earlier, Mound A at Poverty Point is the largest of the oldest earthen mounds in North America, predating Mississippian mound sites like Cahokia here in Illinois or the Emerald Mound in Mississippi. And again, that large mound, Mound A at Poverty Point, is thought to be the last major construction at the Poverty Point site, being constructed around the year 3,400 years ago. But what's remarkable is that there's no evidence of construction stages. There's no clear layers or erosion just mixed basket loads of earth and fill. And based on that and other types of evidence, archaeologists like my postdoc advisor, T.R. Kidder, believe that it may have been built in less than 3 months or 90 days. And that kind of effort raises big questions about the social organization, the labor, and the cultural influence of Poverty Point that it had on resources in lower Mississippi, central Mississippi valleys, and for late archaic peoples living in these regions. Awesome. So building this huge mound, you're going to need a massive labor estimate to build something like this. And based on the material culture found across the site, Poverty Point likely represents a major cultural shift in the lower Mississippi River Valley, especially during the late Archaic. But this wasn't a local site. It was a regional hub. And it's highly sophisticated. It has a highly sophisticated exchange network. These networks not only moved materials, they moved ideas and meaning. So we see copper from Appalachia and Nova Scotia, shell from the Gulf Coast, and then high quality stone that they're getting from elsewhere, from far reaching quarries. And these are all likely not just used for stone tools, but rather to establish status, identity, or build alliances during large gatherings, or a term that's in vogue right now is feasting. So on the map, this yellow star here is the Poverty Point World Heritage Site. North of that, or I guess northeast, is the Jaketown site, which somewhat predates the site, and then the Claiborne site south of that in the Mississippi Gulf Coast, which we now can say also predates Poverty Point somewhat, and is coterminous with it. It might be its own individual population. However, now that we've seen how this approach works for Ozark materials within Missouri and Arkansas, I want to expand the scope of my study. And I want to add those Ozark materials to a larger regional database of stuff that we've collected from both the western and the eastern sides of the Mississippi River. And using this expanded reference collection and the associated spectral signatures, I was able to analyze 862 bifaces from the Poverty Point World Heritage Site and see where it overlapped with these extensive resources. And after running a series of different statistical tests, I was able to achieve about a 58% accuracy rate, where I had multiple models come to the same conclusion on the stone tool source. So now we're able to put a confidence value or a number next to that material. Instead of just looking at a rock and saying, I think it's this, I think it's that, I can say, I'm 48% sure it's Burlington, or I'm 59% sure it's from Knife River Flint, or it's Fort Payne, or what have you. So this can tell us more about the exchange networks. And again, looking at those things from the deposit level within the formation can tell us, least cost pathways and exchange, and how people are more moving across the landscape. So this thing is gonna be the death of me. Awesome. So we spent the last, 7 years trying to go out to different pre-contact quarries, different outcrops, different road cuts. We tried to read the literature, get permissions from local stakeholders, landowners, federal agencies to go out and collect from these different resources. So this is just a map of that representative database within the western and eastern portions of the Mississippi River. So each of those yellow dots represents a collection location within that formation. Forgive me, these are a little wonky. An earlier slide, they're actually within the formation, but this is an older figure. But you can see, we're trying to do our due diligence here and really try to collect the most representative sample of pre-contact quarries as we can possibly do. But again, it just takes more time, effort, research, money. Awesome. So now that we've added these Ozark samples to our database, and going through the previous literature, it appears that there's Burlington-Keokuk at the Poverty Point World Heritage Site, at least through visual analyses. However, after doing my statistics and after adding to that comprehensive database, out of those 862 samples, there's not a single one that is pinging back to those Burlington sources. or when you saw those little ovals, there's not a dot that falls within that oval. So at least for this sample of surface collected bifaces, there's no Burlington. However, when we added a regional expert, Dr. Phil Carr at the University of South Alabama in Mobile, he looked at using his Burlington visual comparative collection and pointed out 21 different ones that could be Burlington. And it's not to say that it isn't Burlington, it's just based on the statistics and the overlap with the visual, it appears that it might be something else. And again, that could be a lack of sample size, that could be several factors, but at least we're doing our due diligence and trying to put a number next to that. And, you know, things aren't always what they seem. So at least for Poverty Point, we're understanding that visual analysis isn't the best way to do it, and it should serve as more as a complementary aspect to analytical Chert sourcing projects, such as my own and others that are developing. And by using these high confidence multi-layered analyses, so combination of visual, petrographic, or geochemical, or in my case, visual and non-destructive reflectance spectroscopy, we're able to more accurately trace the origins of those various materials. Even after increasing the number of our Western samples, even after getting from more quarries and more sites from the Ozarks, in improving our discriminatory power of those models, it appears that some of these resources are more easterly located than we previously thought. And I think a lot of it has to do with the fact that the early Poverty Point archaeologists were all people from Texas. So they were like, oh, this is Edwards. Well, Edwards Formation's huge. It's bigger than, you know, Rhode Island. It's like the King Ranch. It's massive. So I think that's one of the biases. I think that, you know, it might just be a visual analysis. And then, you know, in earlier slides where I had that, this has been my enemy, so I do apologize. Let's see. Yeah, these two materials look quite similar. Maybe I'm crazy, but Nebo flint from Jordan looks very similar to blue-gray varieties from central Tennessee of Fort Payne, which is part of some parts of the St. Louis Formation. So very, very interesting stuff. Awesome. Fantastic. Okay. So it's quite possible that the people had trade relations or exchange relations, or maybe the founding population of Poverty Point in northeastern Louisiana were actually people from maybe central Tennessee or from eastern locations on the eastern side of the Mississippi River, rather than folks from Texas or the Ouachita Mountains or Ozark resources. However, of all the sample, the most western resource that we have is Novaculite and Knife River Flint, and those are very, very small quantities. But the overwhelming majority is Fort Payne and eastern resources like St. Louis. So, in closing, how can we apply this to other things? How can we apply this to other sites? You know, Poverty Point gets a lot of you know, praise and whatnot, but there's, you know, sites like Cahokia, which are even bigger mounds. And I feel like a bad St. Louis resident, because the first time I ever visited Cahokia was last week, and I've been about a year, and I feel really bad about it. I'm really sorry. But what I didn't realize how big the mound was. Oh my goodness. I'm a fool. But all this work is focused on sourcing materials at Poverty Point. It obviously has applicability to other places like Cahokia, in woodland sites and Mississippian sites. And in particular, and I briefly touched on this at the very beginning of the presentation, but Burlington Chert, it offers an important point of comparison. That's because Burlington Point is seen as a marker of early Mississippian interaction, especially in the central and lower Mississippi valleys, northern Arkansas, and at Cahokia. And it's been proposed that these Mississippian villages controlled specific outcrops, that there was somewhat of a kin-based ownership of these resources, or at least it's been postulated that way. But recent sourcing studies as early as, I guess, 2016 or 2017, using another non-destructive approach with PXRF, the results of this suggest otherwise, that people aren't just getting their materials from you know, one certain quarry, but they're getting them from several places. So they're not just going to the Crescent Quarry outside St. Louis. They're going to northern Arkansas. They might be going to southwestern sources or what have you. But this previously done study only has 2 different Burlington sources. So you could add my 5 or my 4, because they also use the Crescent, to tell a bigger story or a more in-depth study. And it appears that, because people are using different Burlington from different locations, people aren't as stagnant as we think. People aren't, people are more fluid, they're more diverse, they're more dynamic, which is a super popular term, and they're interconnected rather than being just a fixed or a centralized population using a finite source within their worldview or their knowledge. And so future work should focus on identifying and differentiating these materials, adding more Burlington sources, adding more Cascade, adding more reed springs, adding more rhyolite, more silexite, what have you, from the Ozarks and other resources to tell a more holistic or more confident story on human behavior in the past, especially at Poverty Point and Cahokia. So thank you.
Anybody have any questions or answers?
Christina.
You said the direct lake in the Flint River was the farthest west resource. Where exactly are those?
Knife River Flint's going to be about 1,060 kilometers to the northwest of Poverty Point in northeast Louisiana. That's in Dunn and Mercer counties, North Dakota. My apologies for not clarifying that earlier. And then the Nabaculite sources are from the Ouachita Mountains of Arkansas, strictly within geopolitical boundaries of Arkansas. And we collected, I think, 24, 25 different pre-contact quarries of Nabaculite with the help of Mary Beth Trubit at Henderson State. Yes.
A question from Facebook.
Yes.
How much variation horizontally and vertically within a single outcrop?
It depends on where you sample. Like you'll go through like a report, maybe like Jack Ray's 2007 work, and you'll see a big outcrop and you'll see different bands in a thing. It's kind of subject to where you pick. A lot of times we'll try to look for a fresh nodule or a spot where it was previously mined from. However, a lot of the stuff that I've done has been where we just have these beautiful nodules that I can just pick up and put in a bucket or crack open with that nice petition. Sorry. Yes, Larry.
Do you see much difference between quarried Burlington and the Creek Burlington with the iron deposits that form in the creek?
Let me get back to you on that because I don't know. Right now what I've been trying to do is, so that early January I zapped all this stuff with my colleague Ryan Parrish, and right now I'm just doing the write-up. I've done the stats, but I'm kind of digging through the literature and trying to figure out what's going on. So yeah, please let me get back to you on that, and hopefully I can answer better. My apologies.
No problem.
All right. Thank you very much.
Do you have a question?
Have another question?
Yeah, just a quick one. The 2 sensors you're talking about,
Yeah.
go over the different ranges, frequencies. How do they, does each one subject the sample to the whole range of frequencies of whatever kind of energy or whatever, and measure what is reflected back? Is that how that works, or?
That's a really good question. It's one individual laser that's, you can't see it, but it's thick, and the field of view of that laser depends on the instrument. So one instrument, now it works fast. Let's see. It's the slide with T-Doll on it. There we go. So you'll have, and this isn't to scale, but this is about 3 centimeters, and this is about a half of a centimeter. So that beam will shoot, here. So it kind of looks like the silencer on a gun for one instrument, and then this instrument's the smaller one, and you'll put that piece of debitage or that projectile point up against it and hold it for 120 seconds. But the beam itself is just a singular thing. It it radiates, absorbs, and then transmits back the laser into the detector, which is this little silencer thing here. And then the flatter the material is, the better quality spectra we get. If we put our greasy paws on it, it's going to mess up the thing. I always get yelled at for doing that. I'm handsy with it. I kind of have clammy palms, so I like to do this, and then Ryan's like, no, stop, this is crappy spectra. So, you want a flat surface, don't want it to be with phalange juices on it, and you want the field of view to make direct contact with the material. Yes?
I was wondering, so just kind of like as a thought experiment, ask you what your thoughts are. There's all these different sourcing locations where people have brought different Cherts to like property point. Do you think that is representative of a family having brought like their favorite Chert with them to property point, or do you think that is just whatever what property point favor and then source of trade? What's your like just theory on that?
Because they're getting things from elsewhere that logistically or within close proximity, there's two different approaches, direct and indirect procurement, but the only thing that separates indirect versus direct procurement is intent, which you can't measure. And so, I'll be in Appalachia and, I have this Ohio variety of Upper Mercer, and on the way back, I'm going to go to this Appalachian source and grab some steatite in mine and, make that big bowl and then, extract it out of the thing and then bring it with me. So that would be somewhat of indirect procurement or embedded procurement. I don't know. The big thing is, and also my sample size is biased because I'm looking at complete to mostly complete bifaces. I'm not looking at the tool reduction or the core or tool production of that material. So what I did for my dissertation was actually look at the not sexy stuff. I would look at the excavated material, not the nice bifaces, but the debitage, which I've yet to publish. But using that kind of stuff, we can actually, put it into layers of the law of superposition through times with radiocarbon dates, with the high confidence sourcing stuff to see, okay, where is it? How is it? And then say, okay, are they using the local stuff at the earliest stages, or are they using foreign stuff? And then you can say, okay, it's probably a foreign population. How far are they coming from that foreign population? Are they coming from North Alabama, or are they coming from Iowa, Missouri? So that changes everything. And I don't want to crib this from a colleague, but there's quite a reasonable argument for bundling. So, bringing all your good stuff with you and then depositing it there. But that's not my idea. That's another person's. So, thank you, Maggie Spivey. Yeah. Any other questions? Awesome. Well, thank you all so much.